So dear friends and colleagues, I'm so disappointed that I wasn't able to join in person. This is definitely one of the few trips I was truly looking forward to. But I guess, the good news is I'm here at least on the screen. And also I want to say that even though I'm supposedly in New York, I never really left California. It's a myth, because my lab continues to function at Collect2, which is a research institute on the UCSD campus. And I spend about 4 to 5 months actually in San Diego every year, for about maybe one and a half to 2 months during winter break, and about 3 months during the summer. And I also continue to visit Los Angeles. So I remain your Southern California colleague, as always. What I'm going to do today is to do first a rather kind of factual, visual presentation of the last 3 projects we have done in my lab in collaboration with students, our researchers, and amazing kind of outside freelance designers and programmers, and then one forthcoming project. And I think what you learn from is perhaps we constitute or examples of a kind of genre which we can call something like urban visualization. And urban visualization itself, trying to visualize the city, the patterns of city life, through the data which is now available to us. Like on the one hand, it points to the terms such as smart city, but it also points to a couple of few hundred years history of visual and spatial representation of a city. So thinking about all the fantastic geographers, cartographers, the modern painters such as Manet, for example, or Sisley, photographers, the modernist photographers, be it Man Ray or American modernist photographers, or projects like Ed Rusher, 1966, every building on Sunset. Right? So when we try to visualize and understand the city life through representation, we're standing on the shoulders, of all these giants, and I think it's something we'll be able to talk more about during the discussion part. So another thing I want to say before I start showing you projects, so I set up this lab, which Todd mentioned, actually in 2007, and we started doing this work around 2008, 2009, and partly, what we wanted to do is take advantage of the available social media data and our large humanities data sets to see what this can do for humanities. How can you write cultural history and cultural criticism, or let's say spatial criticism, in the good big data? But behind these questions there was a larger kind of meta question, right? How can work with big data can help us to question our existing kind of paradigms, methods, and concepts in humanities, such as style, offer, school, ism, our normal view of history is consisting from discrete period, a normal understanding of cultural activity is also something which can be fit in a number of categories, city, countryside, urban, non-urban, impressionism, post-impressionism. Right? So thinking about how the combination of big social data, computation, and interactive interfaces and interactive computer graphics can help us to create not just new visual representations, but new intellectual constructions, right, which will help us to think in more nuanced, more complex, and more subtle ways about our cultural and social histories in the present. Now, I'm not claiming the projects I'm going to show are already doing it. I think we're nothing but maybe in small footnotes towards something which doesn't exist yet. But nevertheless, I've been very happy with the progress we made. So let me kind of share what we've done just over the last 16 months. Okay, so I'm now going to switch the screen to share the desktop. Okay, so the first project is called Photo Trails. We published this in July of last year. So that was our first attempt to make something out of large number of visual social media contributions. For this project, we downloaded 2.3 million Instagram photos from 13 global cities. And when using basic techniques of digital image analysis and visualization, we try to kind of compare the kind of visual signatures, right, the global patterns of the cities using visual characteristics of these images. So each of the project I'm showing you has a dedicated website. In this case, it's bullettrails.net. So you can explore it on your own. You can explore it right now if you have a connected device. But in this case, just to be able to do it faster, I'm actually showing you some of the key visualizations using Photoshop. But they're all available. Like everything we do is available on websites, and you can also. But you can see why I'm going to use Photoshop, because it can take a few seconds to load. So let me switch to Photoshop. Okay. So I'm going to go through a series of visualizations where we took, this whole 2.3 million data set, which was sampled, and then selected 50,000 image samples from each city, and visualized them in such a way that the color, the average colors of photographs, go around the clock, right? Red, blue, green, yellow, red again. And the average brightness goes, from inside to outside. So this is Tel Aviv. The images were downloaded during the same time, which was the spring of 2012. So here's Tel Aviv. Here's Tokyo. Here's Bangkok, and here's, okay, sorry, when you showed, okay, oh, so this is Tel Aviv, sorry, I made a mistake. Okay, this is also Tel Aviv, but this is organized differently. So in this case, we're kind of including the time. So we're only using one coordinate, which is latitude, right? And then the images are organized also by times. What you have is 1 week, and you see, all the different days, and you can see that something special happening this day, which in fact happened to be the most important national celebration, the day of remembrance of fallen soldiers and independence. People go out, run fireworks, and you can immediately see this activity is indicated in different patterns in this day. Right, so here you can see how simply looking at the images without even considering their content, but simply considering their quantity and visual characteristics and distribution of the time, we can, for example, differentiate between different days and see kind of the city response to a particularly important event, right? But if you go to these previous ones, right? So here comes a question, right? Which to me is also one of the key questions for what we can call humanities visualization. Like, what is the right way to interpret these results? Right? On the one hand, if you kind of flip through these images, they look to be remarkably similar. Almost all the colors are represented, but by certain gaps. So here's Tokyo, right? Here's San Francisco, which here's Bangkok. And what is the right interpretation, right? So in humanities, we spend decades arguing how to interpret text with single cultural artifacts. Now we have to figure out, the aesthetics, kind of poetics and the ethics of interpreting visualizations of millions and billions of artifacts. Because you can say, Lev, but the visualization shows all the cities are completely similar. But the city life, as represented by Instagram, and then as re-represented again by visualizations, is kind of the same between Bangkok, Tokyo, or San Francisco, and then somebody else can come and say, no, what we're actually seeing is actually remarkable difference, right? So here in San Francisco, all the colors are present. Here in Tokyo, we have a kind of big gap here, so not that many dark images. And whereas here in Bangkok, we have a different gap right here. And what's interesting, right, there is no scientific, statistical, kind of rational way to interpret this, right? So we really have to think about, what are the right interpretations? Can you say anything? Are there some limits to interpretation? So these questions have to be evolved again in the case of visualization. Another point which I want to make is that, of course, when you visualize and analyze big cultural social data, the results are only going to be as good as your tools, as your methods. So here we're using incredibly kind of rough, approximate, right? And very kind of broad strokes type of analysis, because we're reducing images to only very visual features such as color saturation and average hue, and as a result, we see this look very much the same. But if we take the same data and organize it differently, right? Organize it, visualize it differently, suddenly, like more city specificity comes out, and things don't look the same anymore. So if you look at this visualization, so this is a close-up, right? Now we're going to zoom out. Okay. So you have about 50,000 images, again from a few consecutive days. The upper part is New York City, and the bottom part is Tokyo. Right? So we took 50,000 images, like basically much all jet-coded images which we're able to download, and then simply visualize them, in a one-dimensional sequence where the time goes left to right. But since we do have 2 dimensions, actually it goes left to top to bottom, left to right. So what you see here is that every day has these typical kind of waves, right? The daytime, nighttime, different colors, different hues, which reflect common patterns in the city activity. Right? But at the same time, it's very different, I think, from a typical bar graphs, scatter plots, line charts we've been seeing from statistics, social sciences, and the governments for the last 200 years, because we're not aggregating the data, right? The individual data points, which are actually individual worlds, because each image is like an individual world in terms of richness and semantic potential, is preserved. So on one hand, you can see these patterns, you can see how a variety of unrelated human activities in the cities do actually follow certain broad patterns of the sameness, and yet, if you look at these individual photographs, we're all very different. Yes, some people go eat sushi, some people go eat ramen, some people go play pachinko, and we do lots of different things, and we're not really talking, really natives, but their activities somehow, right, get aggregated with broad patterns, but the patterns have lots of variability. What I also really find interesting about this particular visualization, right, is that if you look at the kind of width of each of this data life cycle, that's very different from city to city, because there are a few images in Tokyo in each cycle. So the same amount of images gives us 4 days, only about 3 days in New York. But also every day the night will be different. So here the transition from morning to day is very, very gradual. Here the transition is much more sharp. So somehow, every cycle is a little bit different. So this is a very, very kind of initial, very broad analysis we did the photo trails. And then they said, okay, that's fantastic, but of course what we're doing is we can take oranges and apples and grapefruits. What we should actually do next is to try to focus on a particular kind of image. So only compare images from different subjects. So our next project, which was also a much larger team, was called Selfie City. So here we use the technique of computer vision, specifically automatic face analysis and visualization and our kind of statistical data science techniques, as well as theoretical essays to create, right, a kind of multi-dimensional, sort of multimedia representation and investigation of the selfie phenomenon. So we started this project in September of last year when the selfie was not such a big thing yet. I already felt embarrassed. We published the project in February. The selfie was going really strong. And I was really hoping that by now it would be forgotten because the project was very successful, but I definitely had a sense of embarrassment because in fact it was so successful. But now it turns out it's okay because I think the selfie emerged as simply stable, popular genre of digital network vernacular photography, like food, pets, and also the city life. So there are lots of parts to it, but let me just take you to the theory part where we have 3 essays which reflect on the project from the point of view of software studies, media theory, kind of feminist theory. But let me take you to what I think is most interesting part, which is the interactive application where people are invited to explore the data set yourself. Right? So we collected a data set of 3,200 selfies. It took us about 4 or 5 months to select this. Actually, it turns out it's not so easy to figure out if the image is selfie or not. And because the web is still kind of slow, so we were not able to show you the whole data set, but the data set does consist of 640 selfies from 5 cities, so a total of 3,200, and you can kind of navigate through it by just browsing through the parts. And then we allow you to filter the data set by various variables, right? So here we have city because we collected these images from 5 different cities. So we can filter by city. For example, here's New York, here's São Paulo, Berlin, Moscow, Bangkok, right? So then here we have age. So for age, we use 2 different techniques. We basically use the state-of-the-art face analysis to estimate the age of a person, and we also gave this data to a few mechanical Turk workers. And actually, it turns out that both human and computer judgments were very correlated, except computer, maybe because it wants us to like it, it always would judge age a couple of years younger, right? But this is also very correlated. And then you have gender, which in this case we also used, the machine, the mechanical Turkers guess, and we did use very simplistically, I know, two genders, but there's a definitely part of it where we couldn't really decide. So part of it is the kind of thing where we couldn't really figure out, right? Not quite sure why, because in some cases it's very obvious, but we couldn't reach a conclusion. And then all these variables here in this part are just some of variables derived by computer analysis. Right? So a computer is able to identify, for example, is the head is tilting to the left or to the right. So here we're going to look at the most extreme tilt, to the left. Okay. Here's the most extreme tilt to the right. Okay, so here we have, for example, some features. We set with some features. For example, are the eyes closed? Okay. Of course, the computer is making a mistake, but if you show it to actually human observers and ask them very quickly to judge, we're also going to make mistakes. So there are mistakes, but I think they're not very bad. And also you have emotions. And what's interesting is that in contrast to the metadata, which is very categorical and binary, right? This image belongs to New York or not. This image is of a male or female. The computer, right, doesn't have this kind of binary mind. The computer gives us continuous variables. So it gives us, for example, about 7 emotions. And notice that with emotions, we have continuous variables as opposed to, so for example, the happy is not just 0 1, so people can be very happy. So this is people who computer thinks are most happy, right? They can be like super unhappy. Okay, or we can be like somewhere in between, right? And also notice when we do selection in any part of the graph, it immediately updates patterns in our part. So for example, this is overall our curve, which shows the distribution of age. And indeed, our stereotypes is true, but it turns out the majority of selfies are in about 20, 21, 26 category. So the average age for all the cities was about 23 and a half, which turns out to be the same age, which is also most typical on OkCupid. So if you guys are OkCupid and posting selfies, I can predict that. Right? But things also get updated. For example, right, if I select Bangkok, notice how there is this green curve, right, which is a little bit to the left, because in Bangkok the selfies are a little bit younger, and so on and so forth. So now if we go back to our kind of results, what we did find is actually significant kind of cultural differences in terms of how people represent themselves on Instagram in different cities. Right? So the previous project for the trails suggests that the network digital culture exemplified by applications such as Instagram, which forces everybody to take pictures which are the same square, the same size, and you have access to the same filter, that become network digital culture imposes certain visual uniformity, in kind of content and visual style, right? This study of a particular popular genre of self-portraits suggests that in fact the cultural, linguistic, ethnic specificity, right, is preserved at least in some ways. So, for example, the smile scores are very different, right? So in Moscow, right, it's just over 50%, whereas in Bangkok is close to 80%, right? Of course, this was, it was even before, all the stuff started with Putin and with the Cold War, right? So now probably it will be even lower. The age is also different, and the pose is also a little bit different. So that was our kind of first attempt to make something which was a little bit more grounded, right, and more specific, as opposed to just simply looking at any images from any city. So now we're going to compare images by over particular time. So the next thing is, very briefly, so this is the next project, where I mostly did everything myself, so it doesn't look as beautiful, but I was also very proud. Of course, we had also a team, but also lots of different parts. So in this case, we decided to kind of focus on a single city and on a small period of time. So the city was a Kiev in over a few days in February of 2014, when the so-called Maidan revolution took place in Ukraine. Right, so over a few days, there was lots of confrontations between the protesters, which were focused on the Maidan Square, the main square in Kiev, and police, the armed forces. Eventually, the president resigned, the president and prime ministers ran away, and the new temporary government was established. So here we basically collected all Instagram photos from the central part of the city. And basically, I spent 7 months doing everything I possibly can to read photos and descriptions to see how the representation of exceptional, which is the revolution, and the everyday Instagram life coexist during this time of exceptional events. Right, so here again, we're kind of making a reference to the history of visual representation. So one of the members of the team wrote this article, which should talk about how revolutions were represented in photography and painting in the 19th, 20th century. Right? So here's the 1848 revolution. Here's, for example, the 1968, and we wanted to compare how these things function on Instagram. So we did this analysis, and we found out that, in fact, in terms of topics, the most popular topics are kind of the same as over the 19th, 20th century: crowd, fire, smoke, flags, other subjects. But of course, there are also lots of differences. So just to take you very briefly for a few visualizations, right? So the idea was to both use very traditional techniques like maps and do very traditional techniques like tag analysis, but also try for visualization to say something different, right? To find particular visual forms which would be appropriate to investigation, which is thinking about, how 6 days of a city get reflected on or represented on Instagram, and there's nothing special about the 6 days. In fact, it just so happens that in the middle of this area, in the middle of 6 days, a revolution took place, right? So here, for example, we simple graphs will show you all the images uploaded every single day, and the red shows you amount of images uploaded on the main square, so you can see how it takes off exactly around the same time when protests get started. So here's a map, right? The area was the area of central Kiev, the day before, and the area of central Kiev over the next 5 days. So of course, the area of protest might not square clearly stands out. But if you slice this data, if you turn to the one-dimensional graph, only plotting count of images versus latitude, in fact, the patterns become much stronger. So here you don't even see the main square, and here it clearly stands out. We also done other works with tags, so I'm not going to go through it. I think maybe one of the most interesting, but just to show you what we've done with, I think maybe one of the most interesting things which I want to highlight, we tried different ways to kind of analyze these images. Right, so what we also try to do is to use a basic data science technique of cluster analysis, where a computer automatically kind of looks at all the images and tries to cluster them into groups where each group has something, where each group images have something in common, simply by the visual features. So the computer doesn't know anything about the content, tags or dates, the computer simply looks at colors. So we got about 60 clusters, where a number of them show you some interesting patterns. So now we start getting into kind of topology of representations of everyday life, right? Everyday life as it is performed on Instagram, which you wouldn't really find if we have normal perception. So here, for example, we find lots of type of city views. So here's one cluster, where a couple images which are basically only Ukrainian flag, but they're kind of masquerading, right, as the city views. So exceptional erupts or exceptional engages for every day, right? So here's another type of Instagram images we found in Kiev. Of course, not only common to Kiev, so people use Instagram as a medium visual communication, not only for photographs. And here different type of portraits, self-portraits. Okay? And finally, just show you one thing for this project, which we think is a kind of almost like its visual logo. So when people tag, right, images on Instagram and also our social network, you typically don't use just one tag. You use multiple tags. So typical image may say something like day, happy, Insta, Maidan, and so on. Right? So when I was playing with this data, completely by mistake, I made the plot where each image was repeating multiple times for each of these tags. And we thought it was so interesting that we have left this mistake, and in fact we made this made a better version of it. So what happens here, we call this visualization speaking of images, right? Speaking of images, where each image is repeated kind of multiple times, right? For each of these tags. I think it's probably still loading, so maybe it was a bad idea to click this button. But you know what's also, but what's interesting, I was very worried, right, about political issues, what will happen, people are going to, somebody's going to say, Lev, why are you utilizing these images? Somebody can arrest these people if Russians come. So I only got like one message. So here is, Andrei Pavikhin from Kiev says, I think I see one of my pictures. I'm like, I'm a responsible American academic, right? I'm like, do you want us to remove, to leave it? Say, hey, leave it, of course. Okay, so that was a very interesting anecdote. So sorry it didn't work out to show you a bigger version, but basically this is, this is a critics. So finally, I probably already kind of went, can I have like 2 more minutes maximum?
Yeah, absolutely.
Yeah, so this is visualization just to show you kind of larger size. Okay. So we just repeated, we choose text. So this is the last one. So the last one is, I think, our most urban project so far. So each of this project takes anywhere between 2 years, 6 months, typically about 6-8 months. So we started working on this already in the spring. So the idea actually came from some of my collaborators, and we had this idea to do a project which would take a single street, right, going through a whole city, and represent the street through a variety of different data sources. So the street that we selected is Broadway, New York. So of course, what would be also very appropriate to select, for example, a Wilshire or Sunset or Los Angeles, because just as Broadway, New York, the cities kind of go for all the different neighborhoods with different ethnic, linguistic, food, income characteristics. So they kind of, the microcosm represent both American cultural diversity and its amazing social inequality. But since we're now based in New York, we selected New York City. So it's an interactive also application. So you'll be able to interactively explore this large data set. It's a commission from New York Public Library. It's going to be installed in the library in December, 9 months. So I'm totally scared, right? Totally terrified. Today I spent the whole day trying to fine-tune the text for a wall, because I knew the text is going to be there for 9 months. And also we have a website. So here you see screenshots from this application, which we're still finishing up. So we're basically using a variety of data sources. We have in the Google Street View. So we have every single image of Google Street View, going looking east, looking west along Broadway, and also looking up. Right? Then another image source we have is Instagram photographs. So we downloaded all the gem-coded Instagram photos, which we shared in New York, like larger New York area, for 6 months in this year. So that was about 10.5 billion photographs. We really selected all photographs, which would go along kind of Broadway corridor, like a kind of spine separating the city. And then subsequently these photographs have been shown, when you interact with application. And then also extracted, for example, some kind of typical most reproduced colors from the both photographs. And we also have data layers, right? So data layers, for example, is taxi drop-off rate for different parts of New York, for different parts of the city as crossed by Broadway. And of course, we couldn't get the data exactly for Broadway, but we tried to kind of went through hundreds of different data sources to try to get the data which would be as close as possible aligned to a very kind of thin kind of stripe, right, a very thin slice along a Broadway spine. So we have taxi data, we have Foursquare check-ins, we have Twitter numbers, we have Instagram numbers, we have median income, we have rent, we have landmarks and cross streets, and we also have neighborhoods. So I'll just show these pictures just to give you an idea of interaction. So what you can do is it's going to be a touchscreen monitor. You'll be able to pinch in and out, pan and zoom. So you can pinch in and then go from the city kind of right very slowly, looking at the images one by one and comparing different image and data sources. And then this what happens if you kind of zoom out, right? So now the images become its kind of stripe, and you see certain pattern, for example, such as the amount of sky, right? So there's obviously much less sky in financial district than in the upper part of Broadway, right? So this is just different screenshots from application, different levels of zoom. Yeah. So I think it's very, very interesting, this experiment to try to kind of represent the city as an interactive application which uses a dozen different sources, which range from the traditional photography, but reimagined for the digital era, i.e. Instagram and Google Street View, to very, right, but which basically represents activities of hundreds of thousands of people on the street, and then the kind of high level of the traditional kind of government level statistics such as income and average rent. So the last thing I'm going to show you is a little video, which kind of a demo of this application on a small screen. So you see we're using Basecamp to collaborate, so I don't even have it as a website yet. Okay.
Do you want to pull that for maybe?
Yeah, so here's our designer basically interacting on a small touch screen with application. So again, like you can pan, and then at any time you can kind of zoom in and out, right? Both in terms of spaces, and explore both the normal kind of visible patterns, the patterns, right, in the realm of optical eye, and the invisible patterns in terms of data, data layers. So now today, in fact, I was looking at correlations to see where any surprises, and so on and so forth. So I think this is it. Sorry if I took more time, but people have the response, and I hope we'll have time for questions and discussion. Thank you.